Okay, all yours.
Okay. So my name is Fermin, and we are with Juan today. We wanted to give a little talk about Git through the console today, and Juan is going to talk about Rebase. And what I wanted to talk about today is the basics of Git. So a few weeks ago, I decided to actually study Git, and I realized how little I knew about it. Also, in my first jobs as a programmer, I used visual tools like SmartGit, and when I had to pick up the console a year ago, I freaked out. I'm guessing I'm not the only one with a similar experience. So instead of talking about super advanced stuff, I just wanted to go back to the basics. So in Git, a collection of version control files are kept together in a repository. And the repository also contains the changes and any special configuration and all files related to a specific project. So in Git, we have three different stages. We have the working directory, the staging area, and the Git repository. And we can also consider the remote repository as a fourth stage of Git. So the working directory is the folder on your computer that holds all the files related to the project, and files within the working directory may or may not be managed by Git, but Git is aware of them. The Git repository is the .git hidden folder inside the project, inside the working directory, that contains the commit history. And the staging area is a place for pre-commit where you queue changes for the next commit. And you can have changes go back and forth from the working directory into the staging area without affecting the Git repository. We also have the remote repository that could be, for example, GitHub or Bitbucket. So what I wanted to do today is just have a local Git project. So if I do an ls, you'll see I'm in the Git app, which is an empty folder. If I do a git init, we need an empty Git project. And if I do an ls-al, you'll see that the .git, which is our local repository. Now, if we do a git status, we have a clean working directory, and I'm going to just create an index.js so we can play around with it and show the difference between the three different stages of Git. So yeah.
Only one thing, like, could you press the button there on the bottom of your screen that say that you allow to share the screen, so it doesn't show that there is a kind of
hide?
like a, yes, hide. Perfect. Thank you.
Okay. Okay. So I created an index file. If I do any changes into the index file and do a git status, you'll see that Git detected that there are changes, but these are untracked. So a tracked file is any file that it's in the working directory and Git is aware of and actively tracking. So we can track the index.js by doing a git add index.js. So what we do with the git add is actually move the file from the working directory into the staging area. And if we commit, right? We are moving that file from the staging into the Git repository. Now let's assume we make any more changes into this. We save and do a git add index.js and git status. You'll see that we have these changes into the Git staging area. And if we do a few more changes, we'll have, and let's clear, we'll have this file in three different stages at this point. So right now we have the index.js. We have one version of it in the staging, one version of it in the working directory, and another version in the Git repository. And we can see the differences between by doing a few Git commands. So git diff without any extra parameters will show the difference between the working directory and what we have staged. So you'll see this is the working directory, and what we have staged, this is what we added previously. If we do a git diff head in caps, we'll see the difference between the working directory and what is in the repository. If we do a git diff without the caps, git diff dash dash staged head, we can see the difference, the comparison within the local repository and what we have staged. Also, Git allows you to have configured graphic tools into your diff. So you can have the best of both worlds, which are the graphic and the console. And first of all, before we talk about this, is that the advantage of having the console is that most support you'll find online will be console and not graphic. So you'll find more support in the web for your problems for console and not for SmartGit. So you can do, I have one configured, which is called P4, so I can do just a git diff to head with just head, and it'll open my graphics comparison tool. And I can also do merges. And these might come in handy if you have some rebase conflicts, for example. Okay, so to compare different branches, I think I just closed everything. Yep. Technical problems.
We are live. Don't worry.
I'm looking for the correct music to put now.
Okay. Let me just do. Okay, there we go. Okay. So I'm not going to do this command because I don't have a remote repository set up. Let me say git up. There we go. To compare different branches from the remote and what we have locally, we can just do a git diff master, where master is the branch I'm currently on my local repository, and then just as a second parameter, we can pass the branch from the GitHub, for example, that we want to compare. That would be, like, for example, origin master. And origin is just the name of the local reference pointing into GitHub. So this will be pointing into the GitHub master branch. Now, going to git add index.js. I'm just cleaning up the environment so we can roll out more changes. Okay, so for the next example I just wanted to show, I'm going to create a full nested folder structure. Let's assume we are creating a React component with a lot of folders. So make dir /p 1, 2, and 3. CD 1. Yes. So we can see that now we have the one folder structure added into the working directory. And if we do a git status, so now we can see that Git will show only the first level files, but it will not show all the files recursively down from this level. But we can sure add them by adding the git add period, which will recursively run all the files from this point forward and add it into the staging area. So if we do this and then git status, this will add all the files into the staging area. Now let's commit this. Okay. So we can always move back any changes from the staging area into the working directory. That's when, let's assume you make a mistake or make any changes into any file, and git add index.js status. Let's assume we don't want these changes anymore. Actually, Git tells you right here what you need to do to move out these changes from the Git repository, from the Git staging area, sorry. So if you do a git reset head index.js and git status, you'll see that the changes are now back into the working directory. And if we command L, and let's say we don't want any changes anymore, so we can just do we want the changes back to what we have when we first brought the branch or the source of code. We can just do a git checkout -- index.js. And if we do a git status, we are back into a clean working directory. Now, another problem, which it was common for me when I was starting to use Git, was file renames, deletions, and moving files, which for me it was kind of scary because when I deleted a file and did a git status, or even when I was working with graphic Git solutions, it didn't show as I wanted it to show. So, for example, let's move into the second folder structure. CD 1, 2. So ls, we have the 2.js file. And if we use the git command to rename a file, git mb, we pass the current name and give us a different name, second file.js, and we do a git status. Sorry. We'll see that Git actually detected the file name change and also staged the change. Okay, so at this point, I can also move the change back into what I have before. If I do an ls and have use again the git command mb second current file name, which is second file.js, and the previous file name, and do a git status, no changes are here. So Git knew that these are the same changes we have on the Git repository and didn't do anything about it. Now let's assume I do this by console without using Git, and I do an mb This is 2.js, and I'm going to rename it to 2.js and do a git status. Now, git detects this to be two operations. One deletion for the 2.js, and we are adding a file which just happens to have the same information as 2.js. So the way we fix this is by using the add command, but this time we'll do a -a. And the difference between using the period and the -a is that -a will also recursively run all the files from this point forward, but it will also update any files that has been moved, renamed, or deleted. So if I do a git status now, I can see that Git is now understanding that this was a rename and not a deletion and adding a new file. So, okay, I'm going to commit change. Okay, so sort of the same thing happens if you try to move a file. If you want to move a file in Git, actually moving a file is just renaming the file into a different folder. So we can just use the same pmb command. So for example, if I do an ls, we have 2.js, and I do a git mb 2.js, and I wanted to move it into 3. ls cd 3 s, and I do a git status. You'll see that actually Git detected this as a renaming to a different folder. So let's just commit this rather quickly. File. And now let's assume that if we try to move the file by using same thing as with the rename. The same thing would happen if I try to move the file with just console command or using the, for example, using Visual Studio Code. And also, if I move into Finder and go into the project folder and move or rename the file, I will also see an operand level file, which is the ds store detected by Git. So it's better to just use the git command to do these sort of operations. Same thing would happen for remove. Now I'm in the third level folder, and if I want to remove the 2.js, I can just do git rm, which is the command for removing files, and 2.js. And if I do a git status, we'll see that Git detected this to be a deletion. If I do this any differently, for example, by doing a git without Git doing a removal, Git would detect that we are deleting a file, but it will not stage the change, and that would be just extra steps that we don't need to worry about if we just use Git. I'm going to just commit this quickly. File. Okay, so to finalize my part, this was a very introductory talk because these are some key concepts about Git that I think they are very important to understand the big picture. So to finalize my part of the talk, I just wanted to mention that you can actually set aliases for Git in the git config file. And this might come in handy for most of you that work with Amazon Workspaces and even up to 2 remotes. For example, let's say that you tend to look at the logs a lot and don't want to write the whole command, which is actually very big. You can do a git git config -- global dot history. That's okay. And this is git config -- global. Sorry, this is global alias dot the name of the new command. And you can do, and here you write the actual command -- all -- graph -- decorate -- 1 line. And let me double check this. Okay, so from this point forward, we can just do the git history, and Git will just run the command I just went through here. So why I think this might come in handy and be helpful for most of you is that I think, and I just read about this, I haven't actually tried it, so I encourage you to try, but I think you can also concatenate different git commands in here, just like you would concatenate any other command with the and operand. So that was it for my end. If there's no questions, Juan, you can move forward.
Okay. Let me share my screen. Okay, my name is Juan. I'm going to continue with this topic about Git. First of all, thanks Fermin for showing this previous content. That was new information for me. And thanks, Mati, for pushing this talk in English, making more challenges. Okay. First, I want to share with you a common configuration that I think is good to know, that we can have a personal project or private project in our laptops. So we need to configure different usernames and email for that. In that case, for example, we can use the global configuration to set the username and the email with the command git config and using the global flag to set that info. And in the case that we want to set that configuration for a particular directory or a specific repository, we can use the same command without the global flag. So in this case, we can have a private username and email for one repository, and for the global, we can have our personal information. Okay, the main idea here is how to integrate change in your current branch. As you may know, we can use merge, rebase, and cherry pick. The main idea in this topic is to talk about Rebase. I only want to show you how we can achieve this. Using merge, this will create a new commit in the current branch that holds of the history of the both branches. The command is git merge and the name of the branch, or the name of the hash of the commit. To cherry pick, we can use this to put only one commit, two commits, or three commits to avoid to get all the history from one branch. So only we need to use is git cherry pick and the hash of the commits that we want. And in the case of Rebase, the main idea is to have maintain a one-line history in the project. Why that? Because this gives you the benefit to have a clean merge of your feature branch in your base branch, so you can identify very easily because you have the new features on top of the history. How Rebase do this is moving or combining a sequence of commits to a new base commit. It's rewriting the history, commit by commit. And the command is git rebase and the name of the branch or the hash of the commit. Okay, a good practice. I always make this when I want to create a new pull request. So first I fetch the remote to get all my local reference updated. And then I pull the branch that I'm going to work. For example, I'm working a feature branch and want to create a new PR for that feature branch from master. So I pull the last changes from master, pull the last changes from the feature branch if it's required. So on this, we avoid to have conflicts when we create the pull request. Okay, what is rebase, or how looks a branch before and after we rebase it? Here you can see we have a master branch with 4 commits and a feature branch with 1 commit differently from the master branch. So in the case we want to get the last changes from master in our feature branch, we can use rebase. And the difference with merge is that we put our current job or our current commit after the last commit from the master branch. In that case, we can have a very line history in our project. The difference is that we change the hash of the commit. We can keep or change the message, but it's always changing the hash. That's why we are always rewriting the history, but not all the history, only our history, starting for our current job. For example, we don't rewrite the history from master. We don't touch the first commit, the second commit, the third commit, or the fifth commit. We are only touching the 4th commit. So that's why I think Rebase is a very powerful utility. We need to lose the fear to use it, because we are not always rewriting the history. Only we change the commits that we want to change. Okay, but we have a common issue, yeah. When we rebase shared and public branch, as you see, we rewrite the history, and if in the case that this is a shared branch, we are going to rewrite the history for the other member of the team, and if they need to pull that changes, it's going to be a very complex operation. It's not impossible, but it's very complicated, and it's not all of the members of the team have the knowledge to using Rebase. Is a mess. Okay, having a lot of commits before Rebase, as what is doing Rebase is putting commit by commit to the new base branch. In this case, if we have a lot of commits or a lot of change, we are going to have a step-by-step for each commit. In this case, if we have a conflict, we are going to pass 6-10 conflicts. Is this a scenario? So to avoid that, I always recommend to squash your commit before Rebase to avoid this situation. Other issue is applying wanted change. In this case, we can apply using Rebase. We can remove any change that we don't wanted, or apply a remove in a commit and drop a commit. But if we don't apply that, we don't need to worry for that. So only do that you want to do, and you avoid this common issue. Mixing conflict change in the process. For example, if we have 10 commits in the Rebase process, and 5 of that 10 commits has conflict with the new base branch, we are going to pass conflict by conflict in each commit. So the main idea is to keep the work only fixing the conflicts and not adding any change in the state, for example, that we know that we add, because we can have that change in the next commit. So only keep the process fixing the conflicts in each operation. Okay. Now I want to show you let me share an example online. Okay. Can you see my screen?
Yes.
Yeah.
Okay. Here we have a master branch with a couple of commits, and we are going to make a rebase. For example, I like the analogy to think that the history of the Git in the current branch that we have is an array of commits. You can think of that is is in that way, so you can easily identify the power of using Rebase. Okay, I'm going to create a new branch from this commit. So we can create this from the terminal in an easy way. We can create a checkout -b, the name of the branch, feature1, for example, and the hash of the commit that we want to create. And now you can see that we have our branch from this commit, from the hash that we previously added. Okay, let me create two commits in this branch. The commits. Feature1, for example. And then I want to create the new commit. Feature. Now you can see that we have these two new commits from the feature one previously we created. Okay. Imagine that now we don't want to be in this base commit, and we want to be on top of the master branch with the last changes. So now we need to pull the last changes from the master branch in our changes to get the last update. In this case, we are going to show you two scenarios. One is going to be squashing the commits, and other is with this normal thing. Okay. If, for example, this shortcode is very useful for me. I always use it. The minus give you the previous branch that you was before, so you can toggle the branch very quickly. Okay, now I'm going to rebase to the master branch. I always recommend to use rebase in the interactive flag, because you see the commits that you are going to work in this process. Because if you don't use it, Git by default pick you all the commits that you are going to have in this new base branch. Okay. Once we start the rebase, we see in this file all the commits that we are going to have after the new base branch. In this case, is master. You can do any command that you can see here. You can pick the commit, you can reward, you can edit, you can squash. For this example, I'm only going to pick the commit. So no need to change anything here. And now we start the rebase process. First, we see the hash of the commit and the name on the message. The difference of merging is that the current exchange is the master. Yes, as you know, when we are merging, the incoming changes are coming from the branch that we are merging. In this case, the incoming change is our changes. So we want to put our change after the current change from the base branch that we are rebasing. That's why our change is in this scenario in the incoming in the incoming part. So we fix the conflicts, we accept both, we add the stage. Here we don't commit anything. We only need to do is git rebase continue. In this process, Git show you the terminal to write the message. If you want to change it, you can change it or not. Now, as you can see, we have the second commit that we saw previously with the same conflict, not the same conflict, but we touched the same file, so we have conflict too. We need to fix that. Imagine that we have 10 commit, and all the 10 commit, we are fixing conflict. It's complicating, it's a bad practice. That is why I recommend to squash all the commits previously made a rebase. And this is a good example for that. Here we can fix the conflicts. And then add to the stage. You can see the message again. Okay, you know that you are done with the rebase when you have this message successfully rebased. I will data the ref and the heads, and you can check the history of your project. Now you can see that your base branch change, you are not in this hash that we previously had. So now you are on top of the master branch with the new 2 commits that are previously rebased. You can see the hash is always changing. You can see that you don't rewrite the history of master. You only touching your current history. So it's not a bad practice. It's not dangerous as we expect, as we know that everything that Rebase is always rewriting all the history of our project, but it's not. It's only rewriting the history of the commits that we are touching. Okay, let me show you the other example, squashing the commit. Okay, we have the same scenario. We are in this branch, with this base branch, with the feature 1. We have these 2 new commits, and we want to be on top of with the last update from master. So we are going to rebase it again, but with a better strategy that is squashing. Okay, we can apply a rebase in the interactive way without changing the base branch, only changing our current history. In that case, we can use the head, moving or changing the commit that we want to change from the head of below. For example, I want to change the last commit, I use 1. I want to change the last 2 commits, I use 2. The 3 commits, I use 3, and something like that. Okay, in this case, I want to change only the last 2 commits. Okay, this is a good opportunity to show you an example how to edit a commit. Suppose that I want to change the name of the first commit because I did a mistake. I put the wrong username and the wrong email. Okay, I can put here to edit this. I can save this file. So I continue this rebase. I am not changing my history, only my current work. I am in the first commit, as you can see, this, and this is the message. So I can apply here an amend. Change the information of my author. I can change the author. Now I want that the name is John Doe, for example. And John.com. Okay. Now I start the process. As you can see, the author is changed. We can change the name, the message if we want. If we want, change author, for example. Here you can see that we are going to continue with the process. We have a new hash. You can check the log2 in this moment and see the changes. We change the previous commit. Okay, here you can, and now you can continue with the process. Okay. If we don't have any conflicts, we are not going to see the previous step that we fix the conflicts or that we change the message or something like that, because we set the flag in pick and we don't edit that commit. We keep the same structure. So now we can see the log that we have this commit with the message changed and the user. And in the last commit is the same, only with a new hash. The previous commit, the feature one, and the first commit is the same. We don't touch that. We don't rewrite. We don't change the hash. It's the same hash, as you can see here. It's the same hash. Okay, now the main idea is rebase this branch, but squashing. Okay, first, I want to squash the last two commits that I previously did. In this case, how to squash. Okay, we squash one commit with the previous one. So we need to select one squash that is below other commit. For example, here we can't squash this commit, the first commit, because we don't have any commit before that. So we need to pick this. We can have the scenario. For example, we have here a commit. We have here other commit. We have here other commit. Think that this is a unit test. This to commit for code review, and we want to squash it. Okay, I want to squash this with this to commit, but for the code review, I want to be one commit only. So I'm going to have two commits in this process. Okay, let's squash this. Okay, we are going to pass commit by commit, but we are not going to have any conflict because it's our current job, so it's not good. It's impossible to have conflict. So we are only changing the commit, nothing else. You can see here, this is a combination of two commits. The first commit, this is the message, and the second commit, this is the message. We can dismiss this, comment this line, change the name here. Squash, for example. And then we finish the rebase, and we can check the history that we have only one commit. We have the user from the first commit that we use. If we want to change it, we can apply the amend and change it. In this case, we don't want that. So now I can create the rebase from master. And we are going to have only one commit. So it's only one conflict. In this case, we avoid the two conflicts that we saw previously. We fix the conflicts. We can accept the change. We add to the stage. We don't commit. We make a rebase continue. We can change the name. For example, in master. We save. And now we have our history. Or clean. We had our master commit. We have our changes squashed in one commit. So it's very it's clean. It's easy to see. As you see, we don't saw the two conflicts. We only see one conflict in that process. Other thing that I want to share with you is, as you can see here, we have this commit. Suppose that we don't want that. We don't want this commit in this branch. We want again in the first feature one. Okay, we can make that. Okay, let me copy the hash. We can rebase. With hash. As you know, Git, everything is the hash of the commit. The branch and the tags is a label for that hash. So we can use. We don't need to use the branch or create a branch. We can use the hash of the commit. So as you can see here, now we want to change the base of the branch. What is the commit that we want? We only want this commit. I don't care for this commit and for this and for this. So in this case, I can remove it. Applying a drop and only picking the commit that I want. And it's a good way to work, not making the commit message anything. Please write a good message, use a good message on the commits. No, write test 1, test 2, test 3, test 4, because you're never going to know how is your work because it's too generic. Here you can easily identify your commit, and then you can change anything you want. Okay, I only want to pick this. We're going to have these conflicts. We need to check what change do we want. In this case, we can have, I don't know, I want only these two new constants that I created previously. So that is I wanted. That is why you need to know what do you need to make. Okay, I accept my current change. Okay, now I can add this rebase. Continue. Okay, we have this new squad, the same message, but I want to change or fit, for example. No. Okay, we accomplished the rebase, and now our log is again with the base of the feature one. So Rebase is a powerful utility that we need to, if we understand what we can do with Rebase, we can do a lot of things. And as you can see, we can avoid to cherry pick. We can cherry pick in the same process of the Rebase. And it's not that we are always rewriting all the history of our repository, only our current change. We keep the base history. So that is all that I want to show you.
Yeah, that's great. I just want to add one thing here, and it's basically, this is definitely is not going to rewrite the history of the Git repository, as long as you are not touching, let's say, develop or master branch. So definitely, it's pretty safe to use in your own branch. So as long as you are using it in your own branch, there is no fear to mess up anything. So yeah, this is the only thing I want to add.
Yeah,
this is great.
Correct.
Thank you.
So I remember I have experience in one project that we started using Rebase, and we did the mistake rebasing all the release branch.
Yeah.
In that case, we started having some problems because we saw the same commit, the same message a lot of time, fixing the same conflicts
again and again.
And that is why we start using the Rebase with the interactive mode to check the commit that we are going to work in the process and see or dismiss any commit that we don't want.
Definitely. Yeah, I think kind of thumb rules are mainly, just use Rebase in your own branch and don't use someone else's branch. So just rebase to the main branch. In this case, let's say master or develop branch. So I think doing this, you're good to go. Otherwise, and also one way to verify if you're doing things right is you shouldn't need to force push only just for your own branch. So as long as you're not forcing any push to any other branch, I think you're good to go too.
That's correct. If you need to make a force push, stop.
Yeah.
What I did wrong.
Yeah, this is great. Thank you.
Yeah, really, really great, both of you. Thanks a lot. Do we have any other question for them? Or for me or for Juan?
No.
In the meantime, I asked Juan about the Rebase. Like, I see a lot of value, like in spending the time in learning this and using it, but looks to me that it's really works and it's valuable if everybody in the team will do it. Because if not, if only one will have like a clean history, and then, as you said, like the others will be all mixed and with messages like test 1, test 2, test 3, kind of, it's hard to look at that history and use it for something. So like everybody should be doing this in a project, I think, for taking advantage and really like using like the time that you invest in like cleaning up the history, no? Do you think that this should be like added at the kind of like project level in some kind of like, I don't know, like you don't accept a PR if it's not using Rebase and the history is clean and these kind of things? Like how do you use this in a team, not only for yourself?
Okay, for example, I work in the previous job that I have in. We started using Rebase. We reject any PR without the last changes of this base branch. So and we push to make only one commit. If you are in the PR and you are making change for code review, squash it. And by the end, only keep one commit. But if you forced to your team work in that process, it's okay. For me, it's okay because you can easily find revert a commit or find a bug by one commit. is very useful.
And that it was automatic, or like the PR was rejected like manually, like
Manually.
manually. Okay. There isn't any tool like to do this automatically.
I really don't know. I don't think so, because we want always to to see the PR. If you don't check the commit, maybe we can have a tool in. I know that in GitHub we can run process from Git. If you have, I don't know, 3 commits in the PR, it's always in need to work. So you can block the merge. But it's not. I don't know if we can have the same logic blocking by commits, blocking by the last change of the base branch, for example.
And in this experience that you had in that work, like, do you think it's worth it? Like, do you think like it improved it a lot, like the history and like how useful it was?
Yeah, from that moment I started using always the console, and if I want to check the last changes of one branch or one release, I always have on top of the history the latest changes. So that is why we use that. We can easily find the last changes and check. Oh, in this release we have this feature, this feature, this feature.
Okay, thanks a lot. Any other questions for them?
I like the sound of that silence.
Look like everything is clear. Again, thank you, both of you. Like this was great. I will share the video when it's done, and we can keep talking in the chat, like for any doubts or further questions. So thanks everybody, and see you next week.
Thank you.
Thank you.
Bye-bye.
Bye.
Bye.
Bye.